Hello everyone, welcome to lesson 77 of our Golang course. In the previous lesson, we learned about channels, which makes Go's concurrency model special. In this lesson, we will cover the select statement, which helps us compose channels and bring channels together. So let's get started. The select statement has a very similar syntax to the switch statement. Just like the switch statement, it has cases and a default case. Here we have an example of a select statement. So you can see we do select, we don't need to provide any condition for select, and we have the opening and closing braces. Inside it, we have two cases. The first case is when we are listening for a value on channel 1, and the second case is when we are writing to channel 2. Please note that in this state, the select statement will block, because as you know, these two calls are blocking unless you have some data on channel 1 to read, or you can write to channel 2. So here I have the same statement. We are just reading from channel 1 and writing to channel 2, but the channels have not been initialized, so we should block forever. And as you can see, we got a deadlock, since this call is blocking forever. Although they look very similar, that is the switch and the select statement, they are very different in their working. Unlike the switch statement, the select statement does not evaluate its cases sequentially. If you remember, the switch statement is very similar to a if-else-if block. That is, each case in a switch statement is evaluated sequentially from top to bottom, or from the first to the last case, or the default statement. This is not the case with the select statement. Here, each case is evaluated simultaneously. Whenever channel 1 has a value to be read from, or you can write to channel 2, the code block will be executed depending on which one is available. And as we saw earlier, if none of the channels are ready, the whole select statement will block. So why is this the case? As we discussed, the select statement evaluates all cases simultaneously. But what happens if all our cases or the channels that we were evaluating in our previous case block are ready at the same time? The go runtime is intelligent. The case selection is done by performing a pseudo-random uniform selection. This means each case has an equal chance of being selected. Pseudo-random uniform selection is a technique used to generate a sequence of numbers that appear to be random but are determined by a deterministic algorithm. This means, given that same initial conditions, the sequence will always be the same. Or, in simple words, each case has an equal probability of being selected. Let us see this with example. I'm just going to remove this and write our code. First, I'm going to create two channels, channel 1 and channel 2. As you can see here, both channel 1 and channel 2 are int channels. Now let us start a Goroutine to write onto the channels. Inside it, I'm just going to start a loop that is going to write to the channel. So we are writing to channel 1 the integer value that we get from the range. Then we are just going to sleep for a second to simulate some work. So that's it for a Goroutine. Now let's create another one that will write to channel 2. Here we just change it to channel 2. Now I'm going to write a select statement to read from channel 1 or channel 2, whichever one is available to be read from. So here we have a select statement that evaluates both channel 1 and channel 2. So as mentioned before, both these are blocking when there is nothing to read from channel 1 or channel 2, and both are being continuously evaluated to see if either of these two is unblocked. The Go runtime is making sure that both of these cases have equal opportunity of being evaluated. Now let's run our code to see what happens. And as you can see, we were unblocked as soon as we got something on channel 2. So what happened here was, as soon as we got something on either of the channels, in this case channel 2, we were unblocked and the code executed, and in the end the program exited. But if you notice, we only read from channel 1 or whichever value we got earlier and exited. What if you want to continuously listen on either of these channels and print all the values that are available to us? In that case, we use a for loop. So this is a very common pattern that you will see when working with channels. That is, you have an infinite for loop and you are continuously evaluating both channel 1 and 2. As soon as we get a value on channel 1 or on channel 2, the case is evaluated and the select statement is called again, because we are in an infinite loop. This will ensure that all values are read, and in the end, when there is nothing to read, since we are only writing 3 values, we will block again. Let's now run it. And as you can see, we are getting the values, and after which we received a deadlock because this was being blocked again and again because we only wrote 3 values. In the future lessons, we will see how this condition or how this deadlock is prevented when using a for select statement with a signal channel or a done channel. In some cases, you may want to handle the scenarios where channels may not be ready to read or write to in a given time. In other words, you can execute some code while waiting for the channels to be ready by using the default case. There's also an option to exit after some timeout or exiting the for loop after a given time without guaranteeing that all values are read or not from the channels we are listening to. Let us look at these 2 examples. So in here, I can add a default case and then print a statement. So I am just printing default case. So what will happen is when any of these channels are not ready, the default case will execute since all these 3 cases have equal probability of executing. Let's run the program and see what happens. And as you can see, we got default cases printed to the console because it's an infinite loop. So these 3 values were printed somewhere in the console. You can search them. But after that, since these 2 cases were blocking every time on each iteration of for loop, the default statement worked. Now what if I want to exit the for loop after 1 second? I can do case and then read from the channel that is returned by time after. Let's say 1.time.second. And then inside it, let's say fmt println returning after timeout. Here to break our for loop, I'm just going to return. Let's remove the default case before we run our program. Go run main.go. And as you can see, as soon as the timeout was executed, we exited the program without reading the complete values from channel 1 or channel 2. So from our example, we saw that the select statement only blocks until any channel has an activity. As soon as any channel that we are evaluating with the select statement is unblocked, the code block for that case will be executed and we exit the select statement. If you want to continuously evaluate all the channels, we use the for select statement as we saw in our example. We also saw that for loop is infinite, so the statement keeps on executing or we end up with a deadlock. The best way to counter this is using a done channel, which we will see in the later lesson. But for now, there's another way we can do it, that is using a for loop with fixed number of iterations. So instead of iterating infinitely, I can have a for loop that iterates 6 times. That is 3 each for both the channels. Now let's run our program to see how that works. And as you can see, we received all the values we wanted because we are aware that both channel 1 and channel 2 are written to 3 times each. That is 6 times in total. So a for iteration with limited number of iterations is only valuable when you know the number of values that you want to read or write to the given channel. Again, the done channel is the most preferred way to exit a for select loop. We will also see how context can be used to also exit from the for select loop, but that is something for future lesson. For now, we just want to understand the working of select statement. Please note that the empty select statement will block forever. So if I remove the for loop and just do empty select, this will block forever and we will get a deadlock. And as you can see, we are getting a deadlock saying all Goroutines are asleep. So in this lesson, we learned that the select statement is a very handy tool to compose channels or to work with multiple channels all at once. Then we also saw the for select statement, which is widely used when working with multiple channels. So we saw 2 ways of exiting the for select infinite loop. One was using a timeout and the other one was using a fixed number of iterations. But the preferred way of doing is using a done channel or through a context. We will see how to use the done channel in the next lesson. That's it for this lesson. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding.